Teletubbies come to play.
1, 2, 3, 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sofia Mansara binti Azhar and my ID is RA251136. Today my group gonna present about recycling, construction and demolition waste as binder, aggregates, alkali activated in materials. For introduction, construction and demolition waste responsible for 25 until 30% of the world's total solid waste generated is one of the major environmental concerns. Most of the CW gets into landfills because of insufficient recycling approaches, especially in developing countries. Research study focus on mixed CDW used to contribute to the circle concept of the economy and sustainable development. You guys might be wondering, what is CDW? CDW stands for construction and demolition waste. So the definition of CDW is waste material from new construction, renovation, repair and demolition of building and infrastructure. And for components, concrete, bricks, wood, glass, metal, plastic, insulation and excavated soil. You might be asking what the function of CDW. So CDW as a sustainable replacement for traditional materials and aggregates. As we know, aggregates are granular material like sand, gravel and crushed stone, fundamental in construction for making concrete, asphalt and mortar. But in CDW, aggregate role as a recycled concrete, brick or tile fragments replace natural stone in asphalt and concrete mixes. And for binder, we all know that binder for cement is an essential ingredient that when we mix with water, react chemically to harden and glue aggregates together, with the Portland cement being the most common type alongside alternative like lime, fly ash, slag cement and newer materials. But in CW, binder roll is fine CW particles like recycled concrete or brick powder are used to create alternative binders, often geopolymers which harden like cement. So for the next page is alkali activated materials, or we can call that AAM. AAM means alternative cementitious binders produced by activating aluminum silicate rich materials with alkaline solution instead of using ordinary Portland cement. Aluminum silicate source materials react with alkaline activators, so we known as geopolymer or alkali activated material. So next, types of AAM. We all know that AAM has three types. So the first one is low calcium alkali activated aluminum silicate. Second one is high calcium alkali activated aluminum silicate, and the last one is hybrid alkali activated. So we go through to the first one. Is a low calcium alkali activated aluminum silicate is a material that are activated through the reaction of aluminum silicate precursors with alkaline solution, resulting in the formation of sodium aluminum silicate hydride, or we can call that NaSH, or calcium aluminum silicate hydride, CaSH. So these materials are characterized by their ability to form strong and durable binders, often used in construction and environment application. They are considered alternative to traditional cement due to their lower carbon footprint and potential for high durability in various applications. So for the next one is high calcium alkali activated aluminum silicate, a sustainable binder material akin to cement made by mixing calcium rich aluminum silicate sources like fly ash or slag with strong alkaline activators like sodium, potassium silicate or hydroxides instead of Portland cement, creating a dense strong material like NaSH or CaSH shells with excellent mechanical and durability properties, often used as a low carbon concrete alternative. And for the last one is hybrid alkali activated. The types of aluminosilicate refer to the precursor material used, which can be broadly categorized into low calcium and high calcium sources, often blended together. Okay, so we go to the next page. Is the main materials. Construction and demolition waste, CDW. We use concrete, ceramic, masonry, and mortar waste. For mortar waste, we use each 35%. So the next one is Portland cement or PC, added at 10% to promote curing at room temperature. Secondly, alkaline activators, sodium hydroxide and sodium silicate. And the last one is recycle aggregates. We use fire recycle aggregate, or we can call that FRA, and coarse recycle aggregate, or we can call that CRA. These materials were used to produce binders, mortars, concrete, and solid blocks.
My name is Fitria Hikmayati binti Mahzar. My number ID is RA25164. Okay, for material use, the study utilized several categories of usable waste to create both the cement binder and the aggregates. For CDW sample composition, the initial raw material consists of a mixture of concrete, ceramic, red and white, masonry, and mortar waste. Other materials like wood, glass, and metals are separated out. For alkali activated precursor, a mixture of masonry waste and powder are collected during the crushing of concrete, ceramic, and mortar waste, with each type dosed at 25% by weight. For alkaline activator, industrial grade sodium hydroxide and sodium silicate or water glass. For hydraulic addition, 10% of ordinary Portland cement by weight is added as a replacement for the precursor to allow curing at room temperature 25 degrees. For recycled aggregate, coarse recycled aggregate sourced from concrete waste crushed to 25.4 mm. For fine recycled aggregate are sourced from ceramic and mortar waste crushed to 4.776 mm. Okay, for method of preparation, the methodology for converting this material into usable construction product involve the following steps. Mechanical processing. For crushing and separation, usable waste like concrete, ceramic, masonry, and mortar are manually separated from the raw CDW. For aggregate production, coarse and fine aggregate are produced through mechanical crushing and characterized according to ASTM standard. For precursor grinding, the 25% of mixture of waste is ground in a ball mill to ensure homogenization and achieve a mean particle size of approximately 92.1 micrometer. Okay, next, for synthesis of binder and concrete, for binder optimization, the CDW binder or hybrid cement is created by mixing the precursor, the alkaline activator solution, mixing water, and 10% of OPC. For mixing and molding, the paste is mixed in a Hobart mixer for 5 minutes at a liquid or solid ratio of 0.25. Fresh paste are molded into 20 mm cube, vibrated for 30 seconds to remove air, and covered with polyethylene film for 24 hours. For curing, specimens are cured at room temperature 25 degrees in high humidity condition. For concrete and block formation, alkali activated hybrid concrete or AAHC is produced by combining the optimized CDW binder with the recycled aggregate in a horizontal mixer for 8 minutes. This mixture is then used to manufacture structural products like solid block. Okay, for usable waste, this category primarily consists of material that can be incorporated into production process for new product. For example, it includes concrete waste, ceramic waste for both red and white, masonry waste, and mortar waste. For non-usable waste, This category include waste that are contaminated with hazardous material. Because of environmental regulation, their use is restricted.
Saya Hanis Balkis binti Salim dengan nombor ID RA25112. So, we move to the types of tests. To ensure these recycled materials meet industry standards, we conducted a rigorous battery of tests. Mechanical performance was verified through compressive and splitting tensile strip tests following ASTM standards Class 1. Physical properties were assessed via slump tests, water obsessions, and density measurements. The third is the microstructural and chemical analysis, gave us a deeper look into the materials compositions using X-rays, fluorescence, XRF, X-ray diffractions, XRD, and SEM/EDS analysis plus 3. We also specially test the recycled aggregates for abrasion resistance and organic impurities to ensure durability.
The process for recycling construction and demolition waste into alkali activated materials involves several stages, ranging from the collection and separation of raw material to the production of final product like binder, aggregates, and structural blocks. First, collection and selection of waste. Source material. The process begins with collecting a CDW sample, typically composed of mixed material like concrete, ceramic, masonry, and mortar waste, along with other usable materials like wood, glass, and polymer. For separation, non-usable waste, those contaminated with hazardous material, are restricted. For recycling, specific usable waste like concrete, ceramic, masonry, and mortar are manually separate from the bulk mixture. The second one is mechanical processing and treatment. To utilize CDW as both a binder and aggregate, the separated waste undergo different mechanical treatment. The first one is aggregate production. For coarse recycled aggregate produced from the coarse crushing 25.4 mm of concrete waste. For fine recycled aggregate produced from the fine crushing 4.76 mm of ceramic and mortar waste. The second one is binder production. For powder collection, during the crushing process, fine powder, particulate material 150 micrometer is generated as a byproduct and collected from the concrete, ceramic, and mortar waste. For milling, masonry waste is finely ground. This ground masonry is then mixed with the collected powder from the other waste, dosed at 25% each by weight. For homogenization, the final mixture, the CDW precursor is processed in a ball mill to ensure a uniform particle size, mean size of 92.1 micrometer. Next, synthesis of alkali activated materials. The transformation into a hardened construction material is achieved through geopolymerization or alkaline activation. First, mixing with activator. The CDW precursor is mixed with an alkaline activator solution, typically a combination of sodium hydroxide and sodium silicate. Next, hybridization to a low curing at room temperature 25 degree and eliminate the need for heat treatment. A small amount of ordinary Portland cement, typically 10% by weight, is added as a replacement for the precursor, creating a hybrid cement. Finally, water addition. For mixing water is added to achieve the desired liquid or solid ratio for the paste or concrete. After that, final product formation. For mortar and concrete, by combining the optimized CDW hybrid binder with the recycled aggregate, the material is turned into CDW-based mortar or alkali activated hybrid concrete. Next, for molding and curing, the fresh mixture are poured into mold, vibrated to remove the air, and cure at room temperature in high humidity. And then application. The AHSC can then be used to manufacture structural elements such as high-class structural block.
Hi, Assalamualaikum. My name is Nur Umar binti Ahmad Nazardin and I'm from RA 25168. Okay, today I'm going to explain about the advantage of the CDW. The first one is environmental. It can reduce landfill disposal of CDW and environmental pollution. It supports circular economy and zero waste concept reduces attraction of natural aggregates and raw materials. Also, lower carbon footprint compared to ordinary Portland cement. Okay, the second is technical or performance. Its high compressive strength up to 40 MPa or more at later ages can be used as both binder and aggregates. Its full utilization of CDW. Its low heat of hydration is suitable for mass concrete and good microstructural bonding between binder and recycled aggregates. It's suitable for structural, concrete and precast blocks. Also, the third one is economic practical. It adds values to low value construction waste. It reduces dependence on natural aggregates. It can be cured at room temperature with small OPC addition, 10%. Okay, next is disadvantages of CDW. The first one, it's material variability. CDW composition varies, inconsistent material properties. It requires careful sorting, processing, and quality control. Okay, the second one is technical challenges. The recycled aggregates have high water absorption. It's lower early age strength compared to OPC concrete. Mixed design is more complex than conventional concrete. The third is economic and implementation. Okay, alkali activators such as NaOH, Na2SiO3 can be costly and hazardous to handle. Limited standards, codes and regulation in many countries, not yet widely accepted by industry and practitioners. Okay, the last one is processing issues. Its manual separation and crushing can be labor intensive. Additional equipment needed for grinding and activation. Okay, so I'm going to explain why CDW is useful. Okay, the first one is environmental protection. It reduces the amount of waste sent to landfills, minimizes environmental pollution from uncontrolled dumping. It conserves natural resources such as sand, gravel, and limestone, and supports sustainable development and the circular economy. Okay, the second one is waste becomes a valuable resource. CDW can be reused as aggregates and even as binder. It turns waste into new construction materials such as concrete and blocks. It helps to achieve the zero waste objective in construction. Okay, the third is good engineering performances. CDW-based concrete can reach structural strength. It's suitable for concrete, mortar, and precast blocks. It can perform comparably to conventional concrete when properly designed. Okay, the fourth one is economic benefits. It reduces cost of raw materials, add value to material that would otherwise be discarded. It lowers dependency on imported or natural construction materials. Okay, the fifth one is lower carbon footprint. It reduces use of ordinary Portland cement, which emits high carbon dioxide. It helps the construction industry move toward low carbon materials. Okay. The last one is support sustainable cities. It aligns with UN Sustainable Development Goals. Improve waste management in rapidly urbanizing areas and encourages greener construction practices.
When we look at the result, the study highlights a clear distinction between the use of fine FRA and coarse CRA recycled aggregates in hybrid concrete. A key finding was the microstructural characteristics of the material. We observed a homogeneous interface between the CDW binder and the aggregates, which is heavily dependent on particle size. Most importantly, the mechanical performance remained remarkably stable. The binder demonstrates a strong ability to maintain resistance levels between 32 until 35 MPa, even with the inclusion of recycled aggregates. This proves the material is not just sustainable but structurally viable. In conclusion, this research proved that Alkali Activate technology enables the full utilization of construction waste as both binders and aggregates. By converting what was once considered trash into high-value commercial product like new cements, we are actively promoting a circular economy. These materials meet all necessary structural and durability standards while offering a practical, scalable and environmentally friendly alternative to conventional materials. This approach is a significantly step forward in advancing sustainability within the construction sector.